In this video for Positive Maths, we're going to learn more about angles and the rules that we use when problem solving. So first of all, we have angles on a straight line. On the left we have A and B, and on the right we have three angles A, B and C. So they're all on a straight horizontal line. So angles on a straight line add up to 180 degrees. So on the left, A plus B is equal to 180 degrees, and on the right, A plus B plus C equals 180 degrees. Angles that add up to 180 degrees are called complementary angles. We learned before that a full revolution of a circle or full angle is equal to 360 degrees. So therefore, the sum of the angles at a point, so A plus B plus C plus D plus E, equals 360 degrees. Vertically opposite angles. So angles that are vertically opposite to each other, so here we have A and C are vertically opposite, and B and D are vertically opposite. They are equal in measure. So A is equal to C, and B is equal to D. Corresponding angles. So here we have four parallel lines, A, B, C, and D. We know that they're parallel because of the arrow that's on each of the lines going in the same direction. We also have a transversal X. So a transversal is a line intersecting parallel lines. That's our transversal. So if we have a transversal intersecting parallel lines, it means that the corresponding angles are equal. So if we look at these blue angles, they're all equal in measure. So the transversal creates the exact same angle with all of the parallel lines. If we then look at these angles that I'm marking with the dot, they're also all going to be equal to each other. The angles that I'm marking with a dash are going to be equal to each other. And the angles that I'm marking here just with a little square, they're all going to be equal to each other. Alternate angles are also equal in measure. So how we spot alternate angles is by looking for the shape of the letter Z in a pattern of lines. So in order for that shape of Z to create alternate angles which are equal, the top part of the Z and the bottom part of the Z have to be parallel, which they are in this case. So if we can see that Z shape within a series of lines like this, then we know that the angles inside the Z are equal in measure. We can also extend that Z shape, and again the angles are equal in measure. So we're looking for this kind of classic Z shape with parallel lines, or this extended Z shape, again parallel lines. So the angles that are shaded in blue are equal, and the angles that are shaded in orange are also equal. Interior angles also add up to 180 degrees. So the angle that's marked in orange plus the angle that's marked in blue, together they add up to 180 degrees. So if I call this angle A and this angle B, then we say the measure of the angle A plus the measure of the angle B is equal to 180 degrees. So we need to use all of these different types of rules to solve a problem like this. So we're given different lines, different angles. We're told the measure of three of the angles, so 112 degrees, 40 degrees, and 96 degrees. And then we have to find the measure of the angles A, B, C, D, E, F, and G. So if we start off on the right with the A, B, and C, we can use our rule for corresponding angles to find the measure of B. So again, if we have a transversal and we have parallel lines, then the angle that's here is equal to the angle that's here. So therefore, we know that B is equal to 96 degrees. Now I can very easily find A, because A and B are vertically opposite. So therefore, A is also equal to 96 degrees. I could have used my alternate angle rule here. So if you see, we have this extended Z shape. So without finding B first, I could have also found using that rule that A is equal to 96 degrees. So often there's more than one way to find these missing angles. The next rule that I'm going to use is my straight line rule. So we'll see that with B and C, we have a straight line. If B is equal to 96 degrees, then C is going to be equal to 180 degrees minus 96 degrees. So I will find that C is equal to 84 degrees. Now let's move over to the left side. Again, I can use my straight angle rule to find E. So 112 plus E is equal to 180 degrees. So therefore E is equal to 180 degrees minus 112 degrees. So I find that E is equal to 68 degrees. Again, I can use my corresponding angles to find F. So I have a transversal, two parallel lines, so therefore F is equal to 112 degrees. Again, I can use the same rule to find G. So E is equal to 68 degrees. I have a transversal, two parallel lines, so therefore G is also equal to 68 degrees. For the last one, to find D, I'm going to use my rule for the interior angles. So I know that all of the interior angles, so that's 40 degrees, plus D, plus 68 degrees, add up to 180 degrees. So 40 plus 68 gives me 108, so 108 plus D is equal to 180. So therefore D is equal to 180 minus 108. So therefore D is equal to 72 degrees. So now we've found all of the angles, I'm going to erase all of this information and we're going to work to spot some of the patterns that can help us to find the rules within a shape like this, where there are different transversals, parallel lines, and also other intersecting lines. So if we're using our straight line rule, literally anywhere we have a straight line and two angles or more, we can use the straight line rule. Vertically opposite, we're looking for x's like this. So for example, when we were finding A and B, when we found A, we could easily find B by using the vertically opposite rule. To use our rule for corresponding angles, we're looking for our parallel line and a transversal. So that's how we found that F was equal to 112 degrees and G was equal in measure to E. For our interior angles, again, we're looking for our parallel lines and our transversal. So that tells us that C and 96 degrees add together to make 180 degrees. Then when we want to use our alternate rules, we're looking for Z's within the shape. So that could be here. It could be the kind of extended Z shape over here. But there's several others as well. We could also use this Z in here, kind of backwards. So they're all the patterns that we're looking for when we're trying to solve a problem like this. For more information, visit PositiveMaths.ie, email us at info@PositiveMaths.ie, and follow us on Facebook and Twitter. Thanks for watching.